What's up, guys? I'm going to be starting a new series on crypto zombies. And crypto zombies, what it is, it's an interactive and kind of a beginner school that teaches you all the things technical about blockchain. So I've been learning blockchain technology and I've been investing in cryptocurrency probably for like almost 3 years now. And I've really been interested in it, and I've never really taken a deep dive into like the code that's behind it and developing smart contracts and whatever else, right? So I've taken an interest in that, so I'm probably going to be going through this tutorial because somebody told me that this is one of the easiest ways to kind of get started and to begin to understand what's going on with smart contracts and Solidity and all these things, right? So if you want to follow along, you can do cryptozombies.io. Just head over to cryptozombies.io. I'll leave a link in the description and you can follow along with the videos. So I'm probably going to be doing like one video per chapter, and you'll see what I mean by that in a minute. All right, so let's talk about this. So learn to make smart contracts in Solidity or Libra. We're not going to be doing Libra. I'm not even sure if Libra is a thing anymore. By making your own crypto collectible game. And if you know what collectibles are on the Ethereum blockchain, like I'm assuming like NFTs or something like that, then you know that that's like kind of insane, like what some of these projects have been going for or been worth lately, or how much money people have made on things like NFTs. I don't know if this is exactly like that, but I see crypto collectible and that kind of just rings that bell in my mind. So like I said, we're going to be doing Solidity and not Libra. Solidity is probably the most used smart contract programming language in existence right now, and the Ethereum blockchain is by far has the biggest network effect. So let's start the course here. All right, so I've already kind of gone through the making the zombie factory stuff. I've gone through most of the code. I haven't gone through it entirely. And I'm still learning Solidity. Like, I have not done this entire thing, and I just know enough about like the basics of Ethereum. So we're going to be starting the course here and making the zombie factory. So you think you have what it takes to become a crypto zombie. This course will teach you how to build a game on Ethereum. So it's designed for beginners to Solidity, but it assumes you have some experience programming in another language, something like JavaScript. Yeah, I think if you know JavaScript or really any other language, you'll be just fine learning Solidity. I think if you know a lower level language and a higher level language, you're probably in the best shape to learn something like Solidity. So if you know like C or maybe something like C++ and you know JavaScript, you're going to feel pretty at home here. All right, so let's get started. And we're just going to be doing the overview here. You can see we got our little zombie guy, and I'm assuming he's some sort of collectible on our blockchain here. In lesson 1, we're going to build a zombie factory to build an army of zombies. Our factory will maintain a database of all zombies in our army. Our factory will have a function for creating new zombies. Each zombie will have a random and unique appearance. And you can... Trust me, unique is a big thing on the blockchain. You should really pay attention to like things like unique or non-fungible. In later lessons, we'll add more functionality, like giving the zombies the ability to attack humans or other zombies. But before we get there, we need to add the basic functionality of creating new zombies. All right. So this is going to be called zombie DNA, this little, I guess it's a 16-digit integer. And different parts of this integer will represent different parts of our zombie. So just like real DNA, I guess if it's like real DNA, I don't know anything about DNA. Different parts of this number will map to different traits. So the first 2 digits map to the zombie's head, second 2 to the zombie's eyes, etc., etc. Right, so only have 7 types of heads, so on and so forth. So if we go like this, there's only 7 types of heads. I guess 11 types of eyes, so on and so forth. So if you start to change these sliders, you'll see like, all right, we're creating like some sort of unique zombie here, right? Now, let's see. So for example, yeah, we went over that. You can see like this modulo thing here, mod 7. Then they're adding 1. So if you wonder where like this little algorithm's coming from, if you do this, if you keep modding by 7, you're going to get some number in between 0 and 6. And then they just add 1 so that it'll be between like 1 and 7, right? So we want to count from 1 to 7. When using interfaces and stuff like that, you don't necessarily want to start from 0. All right, so we've already kind of played with this thing. You can see like how these different values map to different kinds of unique zombies. let's get started with the actual tutorial. So let's do a quick overview of what we're going to be taking a look at. And let me make this a little bit bigger. All right. So what we're going to be taking a look at is contracts. And the way I understand contracts is they're kind of like classes. I think if you understand classes and object-oriented programming, you will understand contracts, but there are certainly some differences. State variables and integers. I guess we're just going to be taking a look at integers here and kind of state variables, which I'm assuming live on the blockchain. Math operations, structs, or objects, or object literals, I guess. Arrays, function declarations, working with structs and arrays, private, public functions, more on functions, the Catch Act 256 and typecasting. I don't really know a lot about this. This is kind of where I stopped off when I first started going over it. So I don't know much about this. Putting it all together, and events, the web3.js. So web3.js is essentially a library that you can use in JavaScript that will let you interact with the Ethereum blockchain and your Solidity code, as far as I understand it. And then we will be done with the course here, or the chapter. All right, so like I said, I'm basically learning Solidity, and so like you're just going to be getting my understandings and kind of like what I'm learning as I'm going through all this stuff. So, and I think it's good that I'm learning a lot of this stuff and I'm first going through it, because I'll be hopefully asking the questions that you're asking, or answering small questions that, you know, I have right now too. So Solidity code is encapsulated in contracts, and a contract to me is a lot like a class, like I said earlier. So a contract is a fundamental building block of Ethereum applications. All variables and functions belong to a contract, and this will be the starting point of all your projects. So yeah, a lot like a class. Version pragma. All Solidity source code should start with a version pragma. If you understand like pragmas and compilers and stuff like that, or if you understand like if you've seen them before, you know that like they kind of send messages to the compiler to say, hey, look at this code in a specific way. So a declaration of the version of the Solidity compiler, this code should use, right, so basically we're going to say like use in between, include anything that's like 0.5 and less than 0.6. So 0.6 won't be included, I guess. So for the scope of this tutorial, we'll want to compile our smart contracts with any compiler version in the range of 0.5 inclusive and 0.6 exclusive, right? So you could have like a patch version here. You could have like 0.5, 0.4, and that should compile just fine. Now we want to exclude anything greater than, anything greater than 0.5, right? So 0.6 shouldn't work for our code here. And there's going to be new versions out now. There's probably 8 and 9 and all those things. And the syntax might be slightly different, and some things might be slightly different in the future. But, you know, like the basics usually never change, although I'm assuming this language is probably still in heavy development. So putting it together, here's a bare bones starting contract, the first thing you'll write every single time you start a new project. All right, so some pragma and the beginnings of a contract. So let's put it to the test. To start creating our zombie army, let's create a base contract, or base contract called Zombie Factory. In the box to the right, make sure that it uses some version in between 0.5 and 0.6, and we're going to call it Zombie Factory. All right, so let's just take this here, and we'll copy and paste it over top of that, and we'll get rid of Hello World, and we need to put Zombie Factory. All right, that should be it. So we triumphed, and we can move to the next chapter. All right, so chapter 3, state variables and integers. Great job. Now that you've got a shell for our contract, or we've got a shell for our contract, let's learn about how Solidity deals with variables. So state variables are permanently stored in contract storage. This means they're written to the Ethereum blockchain. Think of this like writing to a database. All right, so these variables are stored permanently on the blockchain. And you can think of the blockchain as kind of like a decentralized database, and there's some pros and cons to being a decentralized database that I won't really get into throughout this video. But there are reasons that you would want a decentralized database. Things like trustless, you wouldn't, if you were dealing with money, essentially you wouldn't want any one single entity owning the database of money, right? Because say this is like, Chris's bank account, right? And someone could just come in here and change it to whatever the heck they want, right? We'd want a trustless scenario here. We'd want this stuff written to a blockchain so that everybody can inspect it, everybody can take a look at it, and everybody's essentially running a copy of it so that people can't just come in and change whatever they want. You do typically lose some performance this way in some cases, but again, this isn't really a video about that. So this would be stored permanently in the blockchain. In this example, we created an unsigned integer, right, or a uint, called my unsigned integer, and set it equal to 100. So unsigned integer, the uint data type is an unsigned integer, meaning its value must be non-negative. And you can probably see how in some cases on a smart contract, you probably wouldn't want negative values, and you probably want pretty big values too, right? So if you're using like a regular integer, basically the size of that value, it won't fit. Because a signed, like a regular int is signed, right? So you notice like in a regular integer, you could store like negative numbers, but that comes as kind of a cost. You kind of have to cut the size in half, and then the other half is for negative numbers, right? And so like regular integers, we'll be able to store, I guess, just smaller numbers. Anyway, in Solidity, a uint is actually an alias for uint 256. So 256, I'm assuming, is the biggest unsigned integer in Solidity. And I guess if you're really optimizing things, you could make something like a uint 8 or a uint 16, 32, etc. But in general, I guess people just use regular uint. And I guess we'll go over some specific cases in the future in a later lesson where we'll use regular integers. Or not regular integers, some of the smaller uints. All right, so let's put it to the test. Declare a uint named DNA digits and set it equal to 16. So let's create our integer here, or let's do uint. I always put onint. Uint DNA digits. And we'll say that equals 16, and we'll put a semicolon. All right, we triumphed. Let's do the next chapter, or the next chapter here. So math in Solidity is pretty straightforward. The following operations are the same in most programming languages. So we have our regular addition, subtraction, multiplication. Division can be a little bit funny sometimes, but since this is a typed language, we shouldn't really have any weirdness. So like if this was like a floating point or something like that, or like in old versions of Python, for instance, you would see you would do 5 divided by 3 or something like that, and it would just immediately floor it rather than giving you a float. But in this case, it's a typed language, so division should be pretty straightforward. And then we have the modulus, so that's for things like remainder. So if you don't know what a modulus is, you can think of it just as the remainder, right? So 5 goes into 13, 5, 10, and then 5 can't go into that 3 right there. So because 5 can't go into 13 again, it goes in 5, 10. So we subtract 13 by 10, and we get 3, right? So let's go. All right, we also have an exponential operator. So people typically know this as caret, right? Like if you write it normally. But in programming languages, I guess like Solidity, and I know Python does it this way too, we can do star star. And this essentially is 5 to the second power, or 5 to the power of 2, and obviously equal to 25. All right, so let's make sure our DNA is only 16 characters. Let's make another, to make sure our DNA is only 16 characters, let's make another uint equal to 10 to the 16, and that way we can later use the modulus operator to shorten the integer to 16 digits. Okay. So create a uint named DNA modulus and set it equal to 10 to the power of DNA digits. All right. So we'll do uint DNA modulus, and we'll set that equal to 10 star star DNA digits, and we'll put our semicolon. All right, and that's it for that chapter. All right, so structs. Sometimes you need more complex data types. For this, Solidity provides structs. And if you know like C or object literals from JavaScript, you probably understand what a struct is, right? So a struct is like our own little data type here where we're going to give it properties or attributes here, right? So this person has an age and a name, and you could add other things too, probably like a place of work or something like that. But this is a simple struct that just has two properties to represent a person. So every person has these two properties if they're a person, right? Like I said, I guess complicated data types that have multiple properties. And we've also introduced a new data type here called strings. So strings are used for arbitrary length UTF-8 data. So, you know, just strings. If you understand strings from any other programming language, this should make a lot of sense to you. Let's put it to the test. So in our app, we're going to want to create some zombies, and zombies will have multiple properties. So this is a perfect use case for a struct. Because remember, we're building a zombie army where zombies will be different, right? So our zombie will have two properties, a name and some DNA to represent the zombie. All right, so let's do that then. Let's do struct zombie, and then we'll open up some curly braces, and we're going to want a string for name, and then we're going to want a uint for DNA. And that should be it. All right, so you've triumphed. Next chapter. When you want a collection of something, you can use an array. There are two types of arrays in Solidity, fixed arrays and dynamic arrays. So a fixed array, like you can see this here, is of type uint, so unsigned integer, and it will have two elements inside of it. Now, when you're indexing in Solidity, I'm pretty sure Solidity starts from 0. So it might get a little confusing indexing. You put a 2 in here when you instantiate it. So it'll only have two elements, but you'll usually do like, okay, then fixed array, and then you'll put like brackets after it and do like 0 or 1 or something like that, right? This is a string, same thing, just type string, so you could keep a bunch, like you could, not a bunch, but you could keep 5 in here. And then you have a dynamic array. So it's still typed though. So you know, in some languages like Python, for instance, you can put whatever the heck you want in something called a list, right? But this is typed, so it will only accept uints or unsigned integers. All right, but you could put as many as you want, as opposed to this one, which you could only put 2. Now, we could also type our array as one of our own custom types, right? Or as one of our structs here. So this is a person array that we're calling people, and it's dynamic, so you could hold as many people in here as you like. And remember that state variables are stored permanently in the blockchain, so creating a dynamic array of structs like this can be useful for storing structured data in your contract, kind of like a database. Again, because you should think of the blockchain as like a decentralized database. That's like the useful part of a blockchain, right? So public arrays, you can declare any array as public, and Solidity will automatically create a getter method for it. The syntax looks like this. So basically a getter method, and if you understand what a getter method is, then then you get it. This is like an object-oriented programming concept kind of, and like an encapsulation idea, but like basically you'll notice that they didn't have a setter for this, right? So we can't set data to it, but we can do a getter on it. So we can get all of the persons or the people in this person array, right? So, but again, we don't have a setter to set that array. So I'm assuming it'll just return us, every single instantiation of person that we added to this array when we put this public modifier on it. All right, so other contracts would then be able to read from, again, but not write to. If we had a setter, they could write to this array. So this is a useful pattern for storing public data in your contract, right? So people will be able to get from this. Now remember, at least on the blockchain, this is something you might want to know, is that setting things on the blockchain typically costs some amount of money, right? Like you got to pay a little bit of like a gas fee to put something on the blockchain. Getting from the blockchain is, as I understand it, like pretty much completely free. So, you should be able to read. It should be very easy to read things on the blockchain. All right, so let's put it to the test. We're going to want to store an army of zombies in our app, and we're going to want to show off all of our zombies to other apps. So we'll want it to be public. So create a public array of zombie structs and name it zombies. All right. So similar to how we have the people one here, we'll go down here and we'll do zombie. We'll give it a type. We'll open up some brackets to, say it's a dynamic array of zombie objects. We'll say that it's public so that other people can access the getter. And then we'll do zombie. No, we'll do zombies. So zombies, like that. And we'll put a semicolon to end that, and I think that's all we need to do. All right, so we have triumphed again. Next chapter. Now we're going to be going over functions, and you can see like Solidity is just, if you've ever learned any other programming language, you got your variables, you got your like object literal here, or your struct. If you know JavaScript, it's more like an object literal. If you know C, it's more like a struct, right? It's called a struct. And then we've got our arrays, which is just like, another strings, arrays, all these different types, right? Like a lot of this stuff should be pretty, like it should come pretty naturally, right? If you know any other programming language. And now we're just adding another tool to our belt here called a function. All right, so we got a function here called eat hamburgers. And essentially it takes in a string type for name, and we have to say that it's memory, and I guess we'll get into that in a minute. And then it also takes in a unsigned integer of amount. And this is a public function, so you'll be able to call it from other smart contracts or something like that. I'm not sure if it's private by default, but we're definitely saying that it's public, so other people will be able to and should be expected to call this method outside of our contract. So this is a function named, right? It takes two parameters, right? For now, the body of the function is empty, right? So you'll also notice that this function doesn't do anything yet. This is kind of more just like a function signature here. It doesn't seem to return anything. There doesn't seem to be like a return type. So it's just like, kind of like a function signature or like a function that doesn't really do anything. We're also providing instructions about where the name variable should be stored in memory. This is required for all reference types. So if you understand what a reference type is, it's not like one of the simple types. I don't know if this Solidity has like characters or anything like that, but you'll see like arrays, structs, mappings, and strings are all going to behave just a little bit differently. And I guess, yeah, we have this thing to kind of go over here and explain it. So what is a reference type? Well, there's two ways in which you can pass an argument to a Solidity function. By value. And by the way, this is not just Solidity. This is like pretty much all programming languages, right? So by value or by reference. And this is an important concept to know. So if you pass something by value, the Solidity compiler creates a new copy of the parameter's value and passes it to your function. So if you change anything about it, right? Like if we sent like DNA digits or something like that into the function, and if it's passed by value, right? Then when we change DNA digits inside of the function, this DNA digits will not have changed. But if it's passed by reference, then it would be changed to like whatever we changed it to inside the function. So you can see how that would like be trouble if that happened for all of our, integers and all that kind of stuff here. So this allows the function to modify the value without worrying that the value of the initial parameter gets changed, right? So like the thing we passed that's already probably has some instantiated value. By reference, which means that your function is called with a reference to the original variable. So if that happens and we change something about it, it's going to change not only inside of the function, but, entirely. Like that thing that was instantiated outside of the function will be changed. So thus, if your function changes the value of the variable it receives, right, the value of the original variable gets changed. So now, another convention you'll have noticed here is that we have an underscore here for the parameters that we're passing to our function. So it's convention, but not required, to start function parameter variable names with an underscore in order to differentiate them from global variables. Now this is a convention, and when you see conventions in programming languages, you should definitely use them. It makes your code cleaner and easier to understand, not only for yourself, but for other people. And there's usually a good reason to do it anyway, right? So if like I won't get into it, but like if you have something like name outside of this, you might end up changing it inside your function. You have like a whole mess. There's also this concept of shadowing in Ethereum, and maybe we'll go into that in the future too. So this is how you would call this function. So this is the name of the function. So you can ignore like all the rest of the junk here when calling a function, and we just call it by name and we pass it two values here. So this one is taking in a name called Vitalik, and Vitalik Buterin is kind of the figurehead of Ethereum. He's one of the initial creators and one of the ones who kind of stayed on. I think a few other popular names you might know are like Charles Hoskinson, or the guy from Polkadot. What's his name? Dr. Gavin Wood. So, but the guy who's still like kind of involved in the face of Ethereum, the really skinny guy. So I'm not sure why he's eating 100 cheeseburgers here. But yeah, so that's who Vitalik Buterin is. So let's put it to the test. In our app, we're going to need to be able to create some zombies, right? So we're going to be probably creating a function that creates zombies. Create a public function named createZombie. It should take two parameters, a name, which is a string, and DNA. So see a name. So we're going to be creating, like, basically we're going to be instantiating structs here, right? So we're going to be saying like a name and a uint DNA that are going to be passed to it. And don't forget to pass the first argument by value by using the memory keyword. All right, and we're going to leave the body empty for now in our function. All right, so let's type out our function. So let's do function. That's not how you spell that. Function, and now we forgot the C. So function, and what is it going to be called? Create zombie. We'll probably end up doing this in a loop at some point. And what does it take? So the first one is a string. So we'll do string memory. Really? I'm not getting anything. So string memory, and that will be name. All right, and a DNA. So that is going to be a uint, and that will be DNA. Now oh yeah, it is public. So we're going to want public. And then we'll open up some curly braces, and hopefully that's all we need. All right. So next chapter, now working with structs and arrays. So creating new structs. Remember that our person struct in the previous example. So we have a struct called person here, and then we're instantiating a array of persons, right, or people. Now we're going to learn how to create a new persons, or how to create new persons, right, or instantiate this thing here and add them to our people array. So we're going to be instantiating a bunch of different persons, and we're going to be adding them to the people array. All right, so create a new person. So person Satoshi, and we got all the names here. If go look up, if you probably know who Satoshi Nakamoto is, or actually you probably don't know who Satoshi Nakamoto is, but you probably know the name. So person Satoshi, we're going to say he's 172 years old, and his name is Satoshi, and he will be represented by the variable Satoshi here, and he will have a type person. All right, add that person to the array. So I guess we have a built-in method on an array called push, and so we're going to push Satoshi onto the people array. So we can also combine these together and do them in one line of code to keep things clean. So we're essentially, this might be a little bit weird for you to kind of understand here, but essentially you could just push this this variable onto, and it represents this, or you could cut out the middleman, right, and cut all of this junk out here and just pass the person, and it'll figure out how to like kind of do that for you. All right, so note that array.push adds something to the end of the array. So the elements are in the order that we added them. So let's see if we have a uint array here of numbers, and this is dynamic, so you could add as many as you want. And then we push 5, 10, 15, right? So it'll be 5, 10, 15. So if we added like, I don't know, 20 onto the end of this, it would be comma 20. It wouldn't be 20, comma 5, so on and so forth, right? So let's put it to the test. Let's make our create zombie function do something. So fill in the function body so it creates a new zombie and adds it to the zombies array. The name and DNA for the new zombie should come from the function arguments. Let's do this in one line of code to keep things clean. So we're going to be essentially taking something like this, and we're going to be passing our values to it in the function. So let's go down like this here, and we're going to do zombies.push. Why is it not got push? All right, push like that. And then what we need to do is pass it a zombie. All right. And how we're going to instantiate it, we need a name and DNA. So the name will be name, and the DNA will be underscore DNA. And that really should be it. We obviously could create, like, we could say, like, zombie equals, and then we could say, take this up here and like put that there and then pass the zombie down too. But like they said, I think it's a lot cleaner to do something like this. All right, next chapter. So chapter 9, private, public functions. So we're going to be talking about the difference between what a private function is versus what this public function is. So in Solidity, functions are public by default. Okay, so they're public by default. It's kind of funny that we would let someone know that it's public then. This means anyone or any other, I feel like they should be private by default. So this means anyone or any other contract can call your contracts function and execute its code. So obviously this isn't always desirable. Yeah, very obviously that's not always desirable. They really should be private by default. I would be big surprised if later on they didn't eventually just make things private by default. It feels like so backwards that they would start from public. Thus, it's good practice to mark your functions as private by default, and then only make public the functions you want to expose to the world. But then why wouldn't I? Anyway, that's kind of funny. So let's look at how to declare a private function. We have our dynamic array here. We have a function. We're calling it add to array. Why would you even? Anyway, it's kind of a funny function that literally just pushes something to an array when you could just literally call this, but whatever. So add to an array. Now it's private. Now you'll notice that we put an underscore there, and I guess underscored functions, if you know Python, that's kind of a convention in Python. I don't know if it is in other languages, but I know it's a convention in Python that if something's private, you should put an underscore in front of it. So this means that only functions within this contract, so if we created another contract called I literally don't know, zombie party or something like that, and then we instantiated this contract inside of it, we wouldn't be able to call anything that's marked as private, but we would be able to call this public method here. So this means only other functions within the contract will be able to call the function and add to this numbers array. As you can see, we use the keyword private after the function name, and as the function parameters, it's convention to start the private function with an underscore array. So let's put it to the test. In our contracts create zombie function, our contracts create zombie function is currently public by default. I thought I was told to make it public. This means anyone could call it and create a new zombie in our contract, so let's make it private. All right, so then we're going to make it private. And we're going to follow our convention and put an underscore there. All right, so next chapter. And we're getting close to the end here. We're already on 10, so if you're sticking through this, you're getting there. So in this chapter, we're going to be learning about function return values and function modifiers. So return values, to return a value from a function, the declaration looks like this. So we're going to say, okay, we got a string greeting, what's up, dog? Function say hello. And I guess we're just going to pass that string down. Returns, okay. Return greeting. That's interesting that we're returning something that I'm assuming just is in the contract. You would usually expect that you would pass something to it or something, right? But anyway, so we're going to say function. This is kind of weird syntax because we're going to have to say what it returns rather than just giving it this. Typically in another language, you would just put something like string in front of this. So function say hello, we're going to say it's public, and then we're going to have to say after its like access modifier here, we're going to have to say returns and then pass it something like this. Now with strings, you're obviously going to have to put this extra memory thing too, and I guess that's why they had to introduce this syntax of having parentheses here. So returns a string memory here, and then we're going to actually just return a greeting, which will be a string, and we'll mark it as memory, right? So it's the function's job to mark it as memory, right? So in Solidity, the function declaration contains the type of the return value, in this case string. All right, so function modifiers. The above function doesn't actually change state in Solidity, right? Because it's really just, this is like a getter, right? It's not a setter. So it doesn't change any values or write anything. So in this case, we could declare it as a view function, meaning it's only viewing the data, but not modifying it. And I'm assuming that does something to make a... All right, let's see. So function say hello, public view, return string memory. So we're going to add this view modifier here. And Solidity also contains pure functions, which means you're not even accessing any data in the app. Consider the following. Right, so you can see like, okay, this is something that's in the app, right? Or it's in the contract, right? Like it's an instantiated variable here. It already has a value. Now this function doesn't need anything. It's like static. It doesn't need anything from the actual contract, right? You pass it stuff, it does something, and it returns stuff back to you. So this thing is what we're going to call a pure function, which I'm assuming would be more like a static function, but yeah, anyway. So this function doesn't even read from the state of the app. Its return value depends only on its function parameters. So in this case, we would declare the function as pure. Note it may be hard to remember when to mark functions as pure or view. Luckily, the Solidity compiler is good about issuing warnings to let you know. I guess if you have a good IDE, you'll see some like warnings maybe here in the gutter, or when you go to compile your contract, it'll probably give you warnings during compilation time to say like, hey, maybe you should go back and, you know, mark this thing as a view or mark this thing as a pure, because it knows, like, if you didn't put this thing as pure, it would know like, hey, he's not using anything from the contract. I should probably be pure, and then kind of give you a pointer to go back there and do that. All right, so let's put it to the test. We are going to want a helper function that generates a random DNA number from a string. Create a private function called generate random DNA. It will take one parameter named _str, which is a string, and return a uint. Don't forget to set the data location of the string parameter to memory. Right. Okay, so let's get started with that function. So function, and we're going to want to call it generate random DNA. And let's see, what's its first thing? It will take one parameter named str. All right, so this thing takes a string. We're probably going to want to say memory. And its name is going to be str. And then return a uint. So the next thing we're going to want to do is, let's see, are we calling it private? Yeah, we're calling this one private. So we'll put private, and it returns a string. So it returns a uint. So we could probably just do returns uint, right? And then we'll just open some braces here. Now what else? This function will view some of the contract's variables but not modify them. So mark it as view. All right. So we'll put view here. I don't know why that one didn't turn blue. And the function body should be empty at this point. We'll fill it in later. All right, let's try that. What's the problem? Returns uint. Maybe does this have to be in this like that? Whoops, nope, don't want to do that. Did I get it right? I didn't want to actually see the answer. Anyway, I think that was it though. Let's hide the answer again. I didn't really mean to click that, but I think what I did here was I did the right thing. I guess you always need those parentheses, even if it's just one singular thing. All right, so let's take another look at this really fast before we get started on the Ketchak 256. It looks like it really just was that. Okay, cool. So we want our generate random DNA function to return a semi-random uint. How can we accomplish this? Ethereum has a hash function, Ketchak 256, built in, which is a version of SHA-3. A hash function basically maps an input to a random 256-bit hexadecimal number. All right, so a slight change in the input will cause a large change in the hash. This is something called an avalanche. I think it's the avalanche algorithm or something like that. And you can kind of see this. Actually, I think I have a thing for it really fast that we can go over. So if we want to generate like a hash, right? So if I put something like ASDF, right? It will generate me a hash. Now, this hash is the same all the time for ASDF. So if I put A, it's always this. See how it starts with CA9 and ends with 8BB? All right. If I put in an A again, if I like delete it, it's something random, but it's always the same. And so what's really hard is like getting this thing and then like going backwards, right? So like it's real easy to like find this, but it's not really easy to like kind of, I guess, go backwards and find out what this thing represents. There's no there's no way for me to take this and then put that into a thing and then have it give me this back, right? And if I got rid of this and copied it first, and I got rid of this like weird number, or not number, but sequence of characters, I got rid of it and then put it back in, you'll notice it'll give me the exact same thing. And I bet even if I put a space, see how different it gets? It's not like it changes in like some little piece. Like, whoops, I guess you can put a space there. But if I put like a space, like the thing changes entirely, right? So it's not really like deterministic, right? It's not like if I put it in A, B, it only changes a couple things. It changes the whole thing. And that's like the avalanche effect, I guess. All right, so let's go back to our thing here. So, it's useful for many purposes in Ethereum, but right now we're going to use it for pseudo-random number generation. All right, so also important, Ketchak 256 expects a single parameter of type bytes. This means that we have to pack any parameters before calling Ketchak 256. All right, so for an example, they're giving us a comment to say what the output will be. So we do Ketchak 256 ABI encode packed, and then we pass it a string. We know that's what it returns. Same with this. And it's every single time. You put AAAAB in there, you're always going to get this. So as you can see, the return values are totally different despite only one character, right? See how we went from just a B to a C here? And there's no pattern between these two values here. There's no pattern. There's no like, oh, okay, if I just like add one here and then subtract one here and then, bit flip this section, like there's nothing really there for us to like find a pattern, right? And it just changes entirely. Not a small change here too, even though it's only a small change in the string. So that's something really important. If you want to really get into like cryptography and stuff like that, it's important to understand things like that. So note, but if you want to just do smart contracts, you just have to believe that this thing works, right? So note, secure random number generation in blockchain is a very difficult problem. Our method here is insecure, so this is an insecure method. But since security isn't top priority of our zombie DNA, it will be good enough for our purposes, right? And security is always really hard. So even when you think that you've got security figured out and like you're some sort of security expert, someone will come through and completely like ruin your day. All right, so sometimes you need to convert between data types. Take the following example. So this is typecasting. So you can imagine you want to go, let's see what they have here. So we have a uint 8, and we're going to represent that by variable A, and we're going to say that's equal to 5. And we have B, and that's going to be equal to 6. Now we're going to have an error because this throws an error because A times B returns a uint, not a uint8. So this thing, what Solidity will do is it will favor the bigger unsigned integer, right? So if you do uint times uint8, it'll return a uint, which is actually a uint 256. At least that's what I'm assuming it does, is it favors the bigger unsigned integer. So it's returning a uint even though we're multiplying a uint8 times a uint, and then we're like, okay, well maybe I'll get a uint8 back. No, you won't. You're just going to get a normal uint. So instead what we can do is we can typecast. And typecasting, what we can do is we can say, all right, we know B is just a regular uint. So what we'll do is we'll cast it to a uint8 by literally just typing uint8 and passing B into the parentheses here as an argument. And I think I explained this about the best as I possibly could. So let's fill in the body for a generate random number function. Here's what it should do. First line of code should take the Ketchak hash of an ABI encoded packed string to generate a pseudo-random hexadecimal and typecast it to a uint, and finally store the result in a uint called rand. Okay, so let's see. Finally store in a uint called rand. We want our DNA to only be 68 digits long. Remember our DNA modulus, so the second line of code should return the above value modulus, DNA modulus. All right, so let's see. The first line of code in our function should probably be something like this here. A little something like this here. We're going to need this, and then we're going to need to pass something into here. So the hash of this string. So instead of this AAB string, we have a string coming from the function, and we're just going to pass that through. And what is this thing? Generate a pseudo-random hexadecimal, typecast it to a uint, and finally store the result in a uint called rand. So we're going to say uint rand is equal to this. But the problem is it probably returns like a string or something. I don't really know what it returns, but I guess we're going to want to typecast it to a uint, so we'll just pass it into uint here. There you go, and hopefully that's right. And we want our DNA to only be 16 digits long, so we're going to end up returning here, and we're going to be returning the above value modulus, modulus the DNA modulus. So we're going to do rand modulus DNA modulus. All right, and let's see. That didn't work. That's because I called this an unint and not a u, or a unit and not a uint. Let's try again. All right, so we got that right. And I hadn't done this one before, so yeah, I'm glad I got that one right, at least on the second try. So chapter 12, putting it together. We're close to being done with our random zombie generator. Let's create a public function that ties everything together. We're going to create a public function, because remember, these are two private functions. This is not really useful as a contract or as a class because you wouldn't be able to do anything to it, right? There's no entry point for you to do anything here. Let's create a public function that ties everything together. We're going to create a public function that takes an input, the zombie's name, and uses the name to create a zombie with random DNA. All right, so that name, whatever name we pass, we're most likely going to pass into here. It's gonna do some magic and give us some random uint, and really what that's returning is DNA. Yeah, so it's generate random DNA. Yep, that's why the function's called this. And then I bet that DNA is going to be passed here along with the original name that was passed here, and that we get into whatever function we have. So create a public function named create random zombie. All right, so let's create random or pseudo-random zombie. And we probably should say function with the function keyword there. And you'll notice I didn't put an underscore because this is going to be your entry point into the contract here. So create random zombie. It will take one parameter named underscore name, a string with data location set to memory. Okay, so it takes one thing, and we know how to do that. So we're going to do string memory. And what's it going to take? A name. All right. And we got memory and all that stuff. Note, declare this function public. All right, so we're going to say, why would I do that, though? It's already public. And it shouldn't be. It really shouldn't be. Everything should be private by default. I'm going to have to, if this isn't an update in a newer version of Solidity, then I'm going to petition. The second line should run the create zombie function and pass it to name and rend. Wait. The first line of the function. Why are we on the second line of the function? So the first line of the function should run the generate random DNA function on name and store it in the uint. Yeah, okay. So we're going to do uint, and what are we calling this? Rand DNA. And then we're going to say that is going to be equal to the function with random DNA. So we're going to do generate random DNA. All right. And let's see. We're going to pass it name because we know that we have a string coming into our function. It's called name, right? We know that generate random DNA takes a string, right? Like a string here, right? And its variable name is string, so don't get that too mixed up. And it's going to use our name to generate us a random DNA. And now we're going to want to create our actual zombie, which is this right here, where we're pushing onto the zombie array here, right? So this is like, creating zombies for us. So now the next one should be create, and you'll notice this one doesn't have a return value, right? So this one has a return value. This one's like a void function. If you understand what void functions are, there's nothing returned from this because it's actually changing things in the contract itself. It keeps adding things to this zombie array. All right, so create zombie. So, and then we're going to pass it the name, which we already have, name, and then comma, the rand DNA. And in Solidity, you have to put these semicolons. Now, the solution should be 4 lines of code, including the closing thing. Yeah, 4 lines of code. 1, 2, 3, 4. I guess they really care that I did it in 4 lines of code. All right, so that's pretty much it for that. And we can move on to the next chapter. So this seems... All right, so events. Our contract is almost finished. It looks like... Honestly, this is pretty good so far. I just want to quickly go over this. So, like, maybe you don't have a great holistic idea of what's happening here. So this is what people will see from our contract. And basically, they'll pass a name in here for our zombie, right? And what we'll do is we'll generate random DNA with this function here. And we went over that. And then what we'll do is we'll create a zombie here, right? And with no return value. And we're going to take the name that we passed in initially and the random DNA that we generated from the name. And what we're going to do is that zombie, if you go and read this function here, the create zombie, is we're just going to push that new, because remember, we're passing name and rand DNA here, and we're going to essentially just pass that to this. That same name and random DNA is coming into name and DNA of a zombie struct, right? So we're instantiating a new zombie, and we're pushing it onto the dynamic zombie array here. All right? So that's kind of what's going on. So now let's get into events. So our contract is almost finished. Now let's add an event. Events are a way for your contract to communicate with something happened on the blockchain to your app or front end. So something is constantly, I guess, listening. So it can be listening for certain events and take action. Or yeah, the front end can be listening for certain events and take action when they happen. So it's like a publisher and a subscriber almost, right? So this thing will publish events saying like, hey, a zombie was created, I don't know if that's the thing that's going to happen. We'll see. And then every single time maybe a zombie is created, imagine that you had a big list of zombies on your front end or something. and then you wanted to make sure to update the UI every single time a new one is created and add that to the list, add it to your like horde of zombies, right? You probably want to do that every single, you'd want to like put an event in one of these things for create zombie, and then tell your front end, hey, there's a new one, update the UI, and show this new zombie that's added. All right, so declare the event. So an event integers, this is like their own event, which is going to be somewhat like different than ours. So event integers added. So this one's going to be doing x plus y, I guess, and a result. So, all right. And we have a function add here. So x and y, and it returns an unsigned integer. The result is going to just add them. Now, before we return, we're going to want to emit, and if you understand like socket programming, if you ever don't know anything with sockets, then you understand like emitting or something like that, right? But we're going to want to emit this event. We're going to say this event just happened. We did integers added. These integers were added. Your front end could then listen for the event. A JavaScript implementation would look something like this. And JavaScript's huge with smart contracts. You'll notice like kind of the reason a lot of people even use smart contracts is because they have a really pretty front end, right? And they're usually written in JavaScript. So your contract.integers added, function error result, and then the result will be, it'll be some sort of object, right? Now I don't know what that's going to look like, but it'll return probably, I don't know, maybe the parameters that were used, and the result, right? So you can imagine if we returned the zombie object, the new one that was just created, we would like emit a zombie every single time, right? Now I don't know if that's what we're gonna do because, like I said, I haven't gotten this far, but you know, let's take a look. So put it to the test. We want an event to let our front end know every time a new zombie was created, so the app can display it. So declare an event called new zombie. It should pass a zombie ID, a name, and a DNA. Let's see. So declare an event called new zombie. It should pass zombie ID, name, and DNA. Okay. So let's do that. Right, because I guess you don't really need a result or anything like that. It could be that you do that, but you don't necessarily need it. So, and fire it there. So where do they want us to instantiate this? Declare an event called new zombie. I guess it doesn't really matter, but maybe we'll put it above the function. So we'll put it here and we'll say event. We'll call it new zombie. And we're going to want to do a zombie ID, which is a uint. So we'll do uint and put zombie ID, comma, and then a name. So we're going to want to do a string and put name. Hopefully it doesn't need like a memory or anything weird. And then DNA, which is another uint. So uint DNA. All right, and we'll put that. That should be the event as far as I understand this section here. Modify the create zombie function to fire the new zombie event after creating a new zombie to our zombies array. So we've now pushed something. There is no return value anyway, so we can just put it wherever. So we'll put it here. Obviously, you probably wouldn't want to put it first, but let's do emit. So we're going to do zombie or new zombie. And let's see, we have a zombie ID, a name, and a DNA. So what is, well, we know what two of them will be, so let's put those in there. We know that the name will be underscore name. We know that the DNA will be underscore DNA. Now, what are they saying that the zombie ID should be? And let's put our semicolon here. So you're going to need the zombies ID dot array dot push returns zombies ID. Okay, you're going to need the zombies ID dot array dot push returns. I don't know if that's, maybe I'm reading it wrong. Returns a uint of the new length of the array. And since the first item in the array has index 0, right? So it's 0 indexed. Array dot push -1 will be the index of the zombie we just created. So store the result of zombies.push -1 in a uint called ID, so you can use this in the new zombie event in the next line. Okay, so let's do something like, let's see exactly how are we going to do this though. So you're going to need a zombies ID, array.push returns 1. Okay, so what we're going to do is I think they just have this thing messed up here. It's like, it's picking up syntax highlighting and it shouldn't. So what we're going to want to do is say uint, right? And because calling this is fine, we're just going to call it in here, but we're also going to get a value back. So we're going to do uint ID is equal to, and this doesn't change what this thing is doing, right? It's just kind of giving us a value back, and it might be a little confusing. And then we're going to put -1 there. And then I'm assuming we just pass the ID like that. That's what I think is going to work here. Let's check the answer. Something went wrong. We have an event, uint zombie ID string, blah, blah, blah. All right, so something is wrong with our new zombie event up here. So event new zombie, blah, blah, blah. Does it give us any like actionable information? I guess not. So let's see. So we have an event, new zombie. Did I do something weird here? So we have uint results. We're passing all this stuff here. It's definitely an issue with the event here. It should pass zombie ID, name, and a uint for DNA. Let's take a look at this here. So new zombie event, new zombie uint, blah, blah, blah. And it really doesn't give me anything actionable or useful here to really go off of. This is how they're passing it all here. It might have something to do with our string. All right, let's see what we got here. What is different between what I did and what they did? Let's put it next to each other here and see where I'm going wrong. So, blah, blah, blah. What? Maybe it just had to come before some other things. Maybe you're seeing something I'm not, but they look pretty similar. I'll have to look into it in the future. I don't know if it's just where it is though. So maybe I missed where those. Oh, it says declare the event here. I missed that entirely. Okay, there you go. So I guess that has to be declared before some other things. So probably put your events at the top, because I was wondering, like, I thought I had that right, but yeah, I must have missed this comment here. So we're gonna want that there. I don't know if that's important or if it's just something that Crypto Zombies cared about. So we'll try and do this again, and there we are. We're good. All right, so web3.js, and this is basically the last part here, and we'll probably get to play around with it, but I don't think there's really much else to do but just understand some of this stuff. Now we can already see that this is going to be, we can see that we have some JavaScript here. So let's talk about what's happening here with web3.js. Our Solidity contract is complete. Now we need to write a JavaScript front end that interacts with the contract. So Ethereum has a JavaScript library called web3.js. In a later lesson, we'll go over in depth how to deploy a contract and set up web3.js. But for now, let's just look at some sample code for how web3.js would interact with our deployed contract. All right, so like they said, don't worry if this doesn't make sense. Honestly, it probably won't all make sense to you, especially if you don't know JavaScript. But everything is kind of just like a learning curve anyway. Like when you go say like, okay, now I understand how to create a smart contract, the next thing you might go and learn totally separate is web3.js and how to use it. There will be extensive documentation. I'm sure all of this will make sense. Vars are a little funny. I'm assuming this is kind of older syntax or something like that. But anyway, so here's how we would access our contract. We're going to create an ABI here generated by the compiler. We're going to create a zombie factory contract address, blah, 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 our factory. So zombie factory contract.at contract address. which is our contract. Now, all contracts, by the way, will immediately get a contract address. That's just something like all contracts have, and it's unique to them, right? So that's why you'll be able to do this, right? So we're creating that, and then we have a button here that creates a random zombie. So we're calling, remember that function we created? Create random zombie? There it is, right? And we just passed that name. So also we're going to be listening for the new zombie event, and we can actually see what it gives us back, right? So var event zombie factory.new zombie function, and then we have the result here. We can ignore the error, most likely. So if error, just return, right? Yeah. So generate zombie and result dot, and you can see that there is some magic that is giving us in the result. We're able to pick some stuff off the object, like the zombie ID that we created or got from the array.push function, the name, and the DNA. So you can see how we can get some values, like how emitting things is kind of useful, just as if only for just debugging your contract in a sense, but just knowing what's happening inside of your contract, right? So if there's some weird stuff happening, you'd be able to see it in this emission, right? So we'll take the zombie DNA and update our image. Yeah, see, so that's what we're doing here. So we're creating this new zombie. Every single time that I put in a new name here, probably what will happen is a totally new zombie will just be generated, and that's almost certainly what will happen. And they just have some code here to kind of, give that stuff to the front end, right? So what our JavaScript does is it takes values generated in the zombie details above and use some browser-based JavaScript magic. We're using Vue.js. Okay, this is Vue.js. I don't know Vue. I know React. Vue's popular too. So to swap out the images, so you'll get a different image every single time, and apply CSS filters. You'll get all the code for this in a later lesson. Okay, so I guess there will be a later lesson if it exists yet. So give it a try. Go ahead and type a name in the box to the right, and you'll see what kind of zombie you get. Once you have a zombie you're happy with, go ahead and click Next Chapter below to save your zombie and complete Lesson 1. All right, so we'll just start typing in nonsense here. So we got Jeff the zombie, and that's what Jeff looks like. Now, the thing is, that's always what Jeff is going to look like, right? So if I go back like this, and I type in whatever, and then I just put in Jeff again, that's Jeff, and that will always be Jeff, right? So if I put in Chris, that's what I look like, right? So you could like experiment, I guess, with different names or whatever. You could just put nonsense in here. I don't know if it'll take numbers, but yeah, it'll take numbers because it's really just a string, right? So anything that you could put in a string will be accepted here. So put in any name you want. There you go, right? So this is kind of what we were working on the entire time, and you can see how it works. Now, this front end is cool that it gives us all that, but the thing driving, actually creating, and all the logic behind, instantiating the zombie and stuff, and adding it, I guess, to the array of zombies. I don't know if we really got too far into that, but like seeing different zombies, right? But you can see a lot of the work that we did there makes a lot of sense now, and especially like the SHA-256 thing, like the hash that we created, right? Each hash represents a different zombie. But you'll remember too that every single time that you type in the same thing, like if I put in A, that's always A every single time. S, there you go. And there's nothing that really makes like A like similar to S or D or F, right? It's like totally random, right? Like if I put in Chris, and then if I put in like if I just change the letter to like T or something like that, it's like a totally different zombie. Now this is just lucky that that guy's like somewhat similar, right? But anyway, so that's us playing with the zombie there. That's pretty much it. You could show it off on Twitter or something. I don't know if it'll open my Twitter here. Just completed Crypto Zombies Lesson 1, blah, blah, blah. Oh, I don't want to do no name. Let's go back here. Let's put my name in there. So we'll do nope. We're gonna want to go back here, and we want to go back and give our zombie my name really fast. So we'll do Chris, we'll do next, do this, And see how they have like a API here to where like you could pass whatever name you want. So you could probably just pass whatever and see it. So we'll send that out, whatever. Yeah, so we'll proceed to the next lesson, probably in another video. You can tell me if you like this video, if you thought it was helpful. I'm doing these for me as well as other people, so this is just kind of what gets me to do it and gets me to explain it as I'm doing it, which is useful for me to learn. And I'll just get into some of the stuff and places where you can find me and find some of this work, and then I'll end the video. All right, so you can, and I'll start here, you can check me out over on Odyssey. So this is like a crypto platform. So if you're cool, you'll come follow me over on Odyssey. You can follow me on YouTube. Let's see, you can follow my GitHub over here. I have some projects. If you're following the channel, you probably know what they are. You can find me over on my website. It has all my social media, things like Discord, even though I'm going to be moving mainly over to Matrix in the future. Obviously you can follow me over on Twitter. I'm not going to spam you with anything. It's just going to be basically like, probably just like a lot of, videos and stuff like that and stupid things like this. Like just, I rarely post on Twitter, honestly. And then every now and then I do, stream over on Twitch and YouTube. I kind of simul stream, and in the future I'll probably stream to Theta as well. All right, so that's pretty much it for this video. If you like the stuff, make sure to hit the like button. And also, if you're not subscribed, make sure to subscribe. And I'll see you guys in the next one.